So this question says the wholesale price P of e-tablet writing styluses in dollars is related to the supply X in thousands of units by this function here, or this equation I should say here. If 3,000 styluses, so that's our first bit of quantitative information, we know that X is in thousands of units of styluses, so I can say for sure that X is equal to 3, since we have 3,000 styluses, are available at the beginning of a week, and the price is rising at 9 cents per week. Okay, so we know P is price, so rising price at 9 cents per week means a change in price, which we can think of as dP dt. So dP dt is equal to 9 cents, which I will write as a fraction, so 9 out of 100. Which one of the following statements is true? And then all of our statements has to do with the supply and whether it's rising or falling. Our supply is related to the term X, which means the question is asking for a dx dt, right? Our change in supply. So that's our question. So the fact that we are provided with a dP dt and ask for a dx dt really means and points towards the fact that we're going to use implicit differentiation to generate a dP dt and a dx dt. So let's start off with this equation that's been provided for us. Let's differentiate implicitly. So using the power rule, this would become 600p dP dt. And then the power rule here, this becomes minus 2x dx dt. And the derivative of a constant is always just 0. All right, so we have an x value, which we know is 3. We have a dP dt, which we know is 9 over 100. We have our dx dt, which we know is what we're looking for, so we don't know what that is quite yet. But we also have this variable p that we need to solve for. So I can solve for p by taking my original equation, 300 p squared minus x squared equals 2691, and plugging in the x value that we know we have, which is 3, so this becomes 300 p squared minus 3 squared equals 2691, which becomes 300 p squared minus 9 equals 2691. By adding 9 to both sides of the equation, I'm left with 300 p squared equals 2700. I can divide both sides by 300. And I have now p squared equals 9. And of course, I can take the square root of both sides of that and get p is equal to technically plus or minus 3. But because p is price, we know that we're not selling the tablet at negative dollars. So we're going to say that p is just equal to 3. Okay, so now I know I'm going to just add that to my list of things that I have here. And so now I can start plugging things in. So I can plug things in from this stage. So I have 600 times p, which is 3, times dP dt, which is 9 over 100, minus 2 times x, which is 3, times dx dt, and that's all equal to 0. If I simplify further, 600 times 3 is 1800 times 9 over 100, minus 2 times 3 is 6, dx dt equals 0. Simplifying here, the zeros and the 100 will go away. 18 times 9, go to my calculator, is 162. So again, 1800 divided by 100 is 18. So I'm just multiplying 18 times 9, which is 162 minus 6 dx dt equals 0. I subtract 162 from both sides to get negative 6 equals negative 162. And divide both sides by negative 6 in order to isolate my dx dt. And I can see that negative 162 divided by negative 6 is 27. So let me just put this over here. So dx dt is equal to a positive 27. Let's not forget that x is in thousands, so our dx dt would also be in thousands. So this 27 really refers to 27,000. And the fact that it's positive means that the supply is rising at 27,000 styluses per week. So that's how we translate all that. Again, I think it's a good idea to just write out everything that the question is provided for you. That provides the hint that we need to use implicit differentiation here. These are related rates, and then we use that to actually implicitly differentiate the equation that's been provided. And then from there, we get everything else that we need. So our answer here is rising at 27,000 styluses per week.